Hello, my name is Michael Grabus, and for my optimization project, I'm attempting the optimization of a 2D airfoil and ground effect for maximum downforce. So a little bit of background. Formula SAE is a student engineering design competition which involves the annual design, manufacturing, and assembly of a center-seated, open-wheeled Formula-style race car. A rendering of Washi Racing's car from 2017 is shown on the right. Race cars built by Washi Racing annually compete at a competition where the main goal is to finish a 22-kilometer autocross-style race. Shown below is a track from one of the competitions that we compete in. An aspect to a well-performing car is having a front and rear wing that create lots of negative lift, otherwise known as downforce, at the cost of creating additional drag. This downforce ultimately creates more traction for the vehicle in turns and increases cornering speeds, therefore decreasing lap times. On to the optimization problem. The goal here is to take a 2D airfoil in close proximity to the ground and maximize the amount of downforce it produces. I currently do computational fluid dynamics research at WashU, so I've already selected the initial high-lift airfoil from my previous studies. The selected airfoil can be represented as a 2 B-spline curve, one for the top and one for the bottom surface of the geometry. These curves will be divided into a certain number of control points which have explicit X and Y coordinates that can be adjusted based off of the CFD simulation force results. The plan is to use a genetic algorithm to drive the iteration of designs and making adjustments of the control points until an optimal solution is reached. The methodology involves a geometry that has been made in SOLIDWORKS, imported into an ISEM, which is a meshing software. The mesh is created to be fine enough to calculate the boundary layer forces on the airfoil, and the whole model is imported to the ANSYS Fluent. The CFD solver runs inside ANSYS Fluent itself. The whole process can be automated via scripting in MATLAB. And the genetic algorithm is a great tool because it can find a global maximum for the downforce value. This problem is significant because the methodology can be used to optimize other parameters such as minimizing drag in a different scenario.